Okay, I am going to be reading through lesson 4.1 today and linking this into my classroom since we've been having some problems with Class Connect. Here we go. 4.1 Atomic Theory. You may have seen scientists busy at work in a laboratory wearing goggles and white lab coats, working with beakers and test tubes. You may have thought, that looks like fun. The scientists probably were chemists. Chemists are scientists who specialize in chemistry. Chemistry is a physical science that deals with non-living materials. More specifically, chemistry involves the study of matter and how matter interacts with energy. Chemistry often is called the central science because it has a connection with all the other branches of science, including earth science, biology, physics, and astronomy. In this unit, you are going to venture into the world of chemistry. You will be learning about atomic theory, matter, the different states of matter, and mixtures and solutions. As you work through this unit, consider these questions. What are atoms and where are they found? How are the basic properties of solids, liquids, and gases alike and different? How are mixtures and solutions alike and different? How does temperature affect matter and solutions? Look around you. Name 10 things you see, any 10 things. The 10 things you just named, no matter what they are, all have at least one thing in common. They all are made of matter. Everything around you is made of matter. In this lesson, you will explore the definition of matter as you learn about atoms and molecules. You will also learn about atomic theory and how it has shaped what we know today about matter. As you work through this lesson, consider these questions. What are atoms and how do we know they exist? How has atomic theory benefited society? In other words, how has our knowledge about atoms benefited the world? So I'm going to open the ebook. And the ebook is called Investigating the Chemistry of Atoms. This book has something important in common with your breakfast. Your breakfast has something in common with your hands holding this book. In fact, everything around you has it in common. Can you guess what it is? All things are made of matter. Matter makes up everything. Scientists say that matter is anything that takes up space. Even if the space is too small to see, matter is still there. But what is matter made of? No matter what, matter is made of tiny particles. They are called atoms. Atoms are the building blocks of everything. They are everywhere. They are the air you breathe. They are the food you eat, the things you touch, and the clothes you wear. They are every part of you. If you could peek inside an atom, you would see a lot going on. First, you might notice its small, tiny packed center. This is called the nucleus. Inside the nucleus are even tinier particles. They are called protons and neutrons. There are usually the same number of protons and neutrons in an atom. Squeezed tightly together, they form the nucleus. Look again, and you will see clouds of particles called electrons. They orbit around the nucleus. The same number of electrons and protons are in each atom. Protons and electrons each have an electric charge. In protons, the charge is positive. In electrons, the charge is negative. Together, they balance the atom's charge. The atom as a whole is neither positive nor negative. Atoms are so tiny, it takes a row of over 1 million of them to cover the width of a single strand of hair. That's how tiny they are. Isotopes. Sometimes there are more neutrons than protons in a nucleus. These atoms are thought of as heavy. They are called isotopes. So you want to be a physicist. If you're very curious and creative, physics might be the field for you. Physics is the science that studies energy and matter and how they interact. These scientists try to answer big and small questions about the universe. What are stars made of? What makes the tides go in and out? Most physicists do research to try to answer these questions. They teach and write about their experiments. Margaret Burbridge is one such scientist. She studies the stars. Her research has shown how heavier elements can be built from lighter ones inside of stars. Her work is definitely out of this world. For a long time, scientists thought they knew all the parts of an atom. Then they learned that there is more. Protons and neutrons are made of something even smaller. They are tiny particles called quarks. Quarks are the smallest parts of an atom. Scientists have worked for more than 2,000 years to learn what we know about atoms. Everything they have learned is part of the atomic theory. The story begins in ancient Greece, and it continues even today. Ancient Greek philosophers like Democritus and Aristotle watched the world around them. Many thought that all matter was made of 4 elements. They were air, fire, water, and earth. Democritus wondered something. Is it possible to break matter into smaller pieces? And can you keep breaking the pieces forever? He decided the answer is no. At some point, there would be a pile of tiny bits that could no longer be broken. He named the bits atoms. It means unbreakable. Aristotle also thought that matter was made of the 4 elements. He added a 5th element called ether, which he believed filled up outer space. He thought that one element could be changed into another. Scientists started to try out this idea. They began a branch of science called alchemy. They tried to change metals such as lead into gold and silver. For hundreds of years, people believed the ideas of Aristotle and the alchemists. And although the alchemists never figured out how to turn lead into gold, they did discover a new element. One person thought he could turn urine into gold because they were the same color. His work led to the discovery of the element phosphorus. Phosphorus is used on the tips of matches, and phosphorus usually has a yellow color associated with it, I believe anyway. Alchemy was used for hundreds of years. No one thought much about the old idea of atoms. Then along came John Dalton in 1804. Dalton was an English scientist. He took another look at the old Greek idea. He thought it was true. Matter really is made of atoms. He said there are many different kinds of atoms. Groups of one kind of atom make up an element. All the atoms of an element are the same. Each atom in an element has the same number of protons, neutrons, and electrons. It also has the same mass. This mass is also called its atomic weight. Dalton thought you could tell atoms apart by their atomic weights. He also thought that atoms were the most basic matter. He didn't think they could be divided any further. Scientists still had questions. Why are elements different? What makes them different? Is it possible to look inside an atom? They would soon discover that atoms are breakable. The alchemists weren't all wrong. It is possible to change elements. By the late 1800s, many scientists used electricity. It helped them to break down substances into their elements. Scientists could find each element's atomic weight. This helped them to find many new elements. And up here, this is a picture of hydrogen. Scientists realized that the lightest element was the gas hydrogen. They assigned it an atomic weight of 1 Dalton. The Dalton is the basic unit of atomic weight. It is named after Dalton, of course. The weight of every other element is figured by comparing it to the atomic weight of hydrogen. Cathode rays and electrons. In 1897, an English scientist named Joseph John Thomson studied a special glow of energy. It came from an electric current run through a glass tube. The tube was empty of all air and gases. This emptiness is called a vacuum. The glow Thomson saw was energy. He called it cathode rays. German scientists believed this glow was made by Aristotle's ether. French and English scientists thought it was caused by some kind of particle that glowed when hit by electricity. Thomson proved that cathode rays were made of particles. He named the particles corpuscles. Thomson believed that all atoms had corpuscles. He also thought that each corpuscle was much smaller than its atom. Corpuscles later became known as electrons. Thomson created the blueberry muffin model of the atom. He believed the atom was a sphere of spongy material with a positive charge. Electrons, which have negative charge, sat in the spongy material like blueberries in a muffin. It was also called the plum pudding model. This model was later disproved, so that was wrong. Radioactivity. Thomson learned that corpuscles could expose film to take pictures. It could even expose film when the tube was wrapped in black cloth. Other scientists studied the same glow that Thomson did. They called this energy source X-rays. Scientists were curious about X-rays. One found that the element uranium made energy even stronger than X-rays. Most scientists ignored this, but a Polish scientist named Marie Curie didn't. She wanted to learn more about uranium and its energy. She and her husband Pierre tested many elements. They found several that made this energy. They named the energy radioactivity. The Curies wondered where the energy came from. Something was happening inside the atom. It held many mysteries. Before scientists realized the dangers of handling radium, people used it for all kinds of things. There was radium butter and radium toothpaste. A paint made with radium was used on watches and airplane instruments to make them glow in the dark. Women known as radium girls worked in factories using the radium paint. Just for fun, they painted their teeth to make them glow in the dark. Yeah, those radium girls became very sick and died of cancer because radioactive elements are just that, radioactive, and they are poisonous. The work of Ernest Rutherford. Ernest Rutherford worked as Joseph Thomson's assistant. His work built upon Thomson's work. Rutherford was interested in X-rays and radioactivity. He studied the element uranium. He exposed it to a strong magnetic field. In this way, he found that it threw off particles to make radiation. He thought the atoms must be made of lots of these small particles. Rutherford used the gold foil experiment to prove it. He shot radiation through a thin piece of gold foil. His results made him believe that the atom has a tightly packed center with other particles going around it. If he was right, Rutherford would prove that the blueberry muffin model was wrong. The blueberries were flying around the muffin, not sitting inside it. He also thought that there might be a particle with no charge in the atom. Another scientist found the particle. It was the neutron. Atomic comet. Work with radioactivity had a big effect on the entire world. Comic books like Radioactive Man, Atomic Mouse, Atomic Rabbit, Inside the Atom, Reacto Man, and Atomic Superboy were very popular in the 1950s and 1960s. Some were written to explain atomic energy and the use of electricity. Others told fantastic stories where radiation turned regular people into superheroes. The work of Irene Joliot-Curie. Irene Joliot-Curie was the daughter of Marie Curie. She was her mother's assistant. Joliot-Curie and her husband studied the radioactive decay of elements. They searched for ways to make radioactive substances in the lab. They found that some substances decay in seconds. Others take millions of years to decay. Their work led to the discovery of fission. Fission is splitting apart the nucleus of an atom. For a very long time, scientists thought an atom could not be split. It is possible, just very hard to do. The split creates large amounts of energy. Joliot-Curie and her husband shared the Nobel Prize in Chemistry in 1935. 20 years later, she died of cancer, just as her mother had. Working with radioactive materials caused the illness. In 1913, a scientist named Niels Bohr worked with Rutherford's ideas. He made a new model of the atom. Bohr's model says that atoms are made of three kinds of particles. They are protons, neutrons, and electrons. There are about the same number of protons and neutrons in an atom. There are exactly the same number of protons and electrons. The nucleus of the atom is a tightly packed center. It has protons and neutrons. Electrons orbit the nucleus like planets orbit the sun. They whiz through the empty space around the nucleus. Later, Bohr changed his mind about electrons circling the nucleus in this way. He thought the orbits were more like energy levels. When an electron absorbs a unit of energy called a quantum, it becomes excited. It jumps up to a higher energy level. The truth is that electrons act more like clouds of energy than particles that circle the nucleus. Atom smashers. Particle accelerators are also called atom smashers because that's what they do. They smash electrons into atoms. This releases energy particles for scientists to study. An atom smasher covers acres of land. To see it, you'd need to take a helicopter ride. Physicists use atom smashers to search for the tiniest building blocks of matter. In an atom smasher, an electromagnet moves a beam of electrons down a copper tube. The tube can be as long as 3 kilometers or 2 miles long. When they reach the end, the electrons smash into a target. Subatomic particles like quarks and radiation are released. The particle zoo. The more scientists studied the atom, the more complicated it seemed. They finally realized there was much more to atoms than they thought. They used machines called particle accelerators or atom smashers. The machines helped them find many new subatomic particles. Subatomic means smaller than an atom or part of an atom. In 1963, a scientist named Murray Gell-Mann thought that all subatomic particles were made of even tinier particles. He called these quarks. He picked the name quark from one of his favorite books. He found 6 different types of them. He called them up, down, charm, strange, top, and bottom. Gell-Mann was only joking when he named the types of quarks, but somehow the names stuck. Atom smashers have helped to find hundreds of subatomic particles. There are so many that scientists call them the particle zoo. The future. Scientists continue to build more powerful atom smashers. They help scientists find new subatomic particles. Scientists aren't sure that the quark is nature's most basic unit. There may always be questions about atoms that scientists can't answer. They have learned enough to put atomic theory to good use. Atomic theory has let scientists develop many things. We now have X-rays, cancer treatments, and atomic energy, artificial elements, new drugs, and atomic weapons. Scientists keep learning more about the atom. They create new ways to use the information. Who knows what the future will hold? And this is a robot. A robot you can swallow. Imagine swallowing a robot so tiny it would take a microscope to see it. Scientists are working on ways to build very tiny objects called nanorobots. Nanorobots are built by arranging atoms one at a time. In the future, it may be possible to program nanorobots to find cells in the human body that cause illness like cancer. These nanorobots would destroy the cancer cells and leave the healthy cells alone. Doctors may even be able to send messages to nanorobots with sound waves to check how many cells they have destroyed. Wow, that's pretty cool. Okay, so we're going to go back to the activity now and move on. Matter is anything that has volume and mass. Consider a book on your desk. Your book is made of matter. Even you are made of matter. Both you and the book have volume, which means you and the book take up space. You and the book also have mass. Mass is a measurement of how much matter is in an object. You can measure mass by using a balance scale. You may have stepped on a balance scale during a visit to your doctor's office. The scale measured the mass of your body. You may be thinking, mass? I thought the scales in the doctor's office measured my body weight. Balance scales do both. Balance scales measure both mass and weight, at least if you're standing on the earth. Mass and weight are the same measurement on Earth. However, if you were an astronaut standing on the surface of the moon, your mass and weight would be different. Because mass measures the amount of matter in an object, your mass would remain the same both on Earth and on the moon. But weight measures the force of gravity on the mass of an object. On the moon, there is less force of gravity than on Earth, which means you would weigh less on the moon than you would on the Earth. If you weigh 45 kilograms or 100 pounds on the Earth, you would weigh only 8 kilograms or 17 pounds on the moon. Whether on the Earth or the moon, what are all things made of? And I hope you can think of the answer, which is all things are made of matter. Let's explore matter further. Consider a book on your desk. Imagine breaking down the book into smaller and smaller and smaller parts. Imagine being able to break down the book into parts too small to see with your eyes. All matter is made of parts too small to see with your eyes. These tiny parts are called molecules, and molecules are made of even smaller parts called atoms. Atoms are known as the basic building blocks of all matter. You may be wondering how we know about atoms if we can't see them. Surprisingly, people today know quite a bit about atoms. Everything we know about atoms is part of the atomic theory, and scientists have been working on the atomic theory for over 2,000 years. Democritus was an ancient Greek philosopher who believed that all things could be broken down into smaller and smaller and smaller parts. He thought that eventually anything could get to its smallest part, at which point it could not be divided any further. Democritus called the smallest part of an atom. In ancient Greece, atom means unbreakable or indivisible. In 1805, John Dalton revisited the ancient theory of atoms. He added some important information to the atomic theory that Democritus had begun over 1,800 years earlier. Dalton used a scientific measurement to develop a model of atoms, as well as theories about how atoms behave. Because of his discovery, John Dalton is known as the founder of modern atomic theory. Over the years, other scientists have contributed to the atomic theory. We now know that Small as atoms are, every atom is made up of even smaller particles called electrons, protons, and neutrons. We also know that when two atoms fit together, they create a molecule, and when many molecules fit together, they create matter. The following words are all part of the atomic theory: atoms, electrons, protons, neutrons, matter, and molecules. As you have learned, you cannot see any of these things because they are so small. However, relative to each other, these things do vary in size. Arrange these words in order from largest to smallest atoms. So which is the smallest and which is the largest? Molecules would be the largest, or sorry, matter would be the largest. Matter is made up of molecules. Molecules are made up of electrons, protons, and neutrons. Now, once again, consider the definition of matter. Matter is anything that has volume and mass. If matter includes everything around us, what about air? You can't see or hold air, so does air have volume and mass? When scientists say everything is made of matter, does this include air? And the answer, of course, yes. Air is made of matter because air has volume and mass. Air has volume and takes up space. Because air takes up space, you can blow up a balloon. A balloon filled with air has more mass than an empty balloon, right? So you can actually see the air. The ancient Greek philosopher Democritus, the English scientist John Dalton, and other scientists from long ago were never able to see atoms. Though these scientists believed that atoms were very, very small, do you think they would have been surprised to learn how small atoms really are? Atoms are so small that 1,000,000 of them could fit on the period at the end of a sentence. We know that the ancient philosophers and scientists were unable to see atoms, but what about today's scientists? Do you think they are able to see atoms? Why or why not? Even modern day scientists cannot see atoms. Atoms are too small to be seen. So how do we know that atoms exist? Scientists have developed advanced technology that allows them to observe the characteristics that atoms exhibit. In other words, even though atoms are too small to be seen, atoms and their similar parts are studied by how they behave. Scientists are able to study the behavior of atoms using technology such as electron microscopes and scanning probe microscopes. And new technology to support and advance atomic theory continues to be designed and tested by scientists every day. Because of atomic theory, scientists have made developments and advancements in the areas of X-ray technology, cancer treatments, and flat screen technology, just to name a few. What will the future hold as scientists continue to expand their understanding of atomic theory? Okay, so we are going to stop here, and we will actually look at the investigation at another time, and we've reached the end of the lesson. All right, so I will be posting this online for those of you to listen to.